In this video, we will learn limit, continuity and differentiability of a single variable function. So first we will learn concept of limit. So let us say we have a function fx is equal to sin x upon x. Now if you want to know value of this function at point x is equal to 0. So if you want to find f0, then you have to put x is equal to 0 in this equation. So it will be sin 0 divided by 0. Now division of 0 is not defined. So you cannot find value of f of 0 directly. So you have to apply concept of limit in order to find value of f0. Now I will explain the process of finding the limit of a function. So if you want to find limit of function at this point, let us say x0 is equal to 0, then you have to take small interval at both the side of this x value. Let us call this small interval delta, and let us take delta is equal to 0.5. We can take any arbitrary value. We can also take 0.8, but we have to take delta as small as possible in order to minimize the calculation. So here it will be negative 0.5 and here it will be 0.5. Now we will calculate left hand side limit. So we will approach x is equal to 0 from left hand side of this point. So we will go in this direction. So we will take value, next value 0.7, then after 0.9. So if you take value of 0.7, then you will get fx is equal to, let us say 0.9, and for 0.5 it is 0.8. Then if you take value of minus 0.9, then you will get negative 0.91. fx is equal to negative 0.91. Thus, if you approach to value of x0 step by step, then eventually the answer will be close to 1. So we can say that as x approaches to, here we are approaching this value 0 from left side. So we will write left hand side. So this limit will be called left hand side limit. So limit x tends to 0 from left hand side, then function fx will approach to 1. So we can say that left hand side limit is equal to 1. Now similar way we can do this process for finding of right hand side limit. So we can take 0.7, then we will get value of 0.8, similarly 0.9, and thus we can approach to this particular point 0. And as we approach to x is equal to 0, then function fx will approach to this value 1. So we can say that limit, right hand side limit, for right hand side we will write r tends to 0, fx is equal to 1. Now here left hand side limit and right hand side limit are equal. They both are same value, which is 1. So we will say that this function has a limit at this particular point x is equal to 0, and its value is 1. So limit do exist for this function at this point. So we can write limit x tends to 0, fx is equal to 1. Here fx is sin x upon x. So we can say that value of f0 is equal to 1. Now for any function, if you want to define its limit, then the function must follow 3 rules. It must have left hand side limit, it must have right hand side limit, and both limits should be equal. If these 3 rules are satisfied at particular point, then we can say that the function has a limit that is defined at that particular point. So we will summarize the condition for limit to be exist at any point x0 for function fx. So first rule is left hand side limit must exist, right hand side limit must exist, and both limits must be same. Left hand side limit should be equal to right hand side limit at particular point x0. Then we can say that limit x tends to x0, fx0, fx is defined. Now we will talk about continuity. So in our function sin x upon x, now this function is continuous for each and every value of x except x is equal to 0, because for x is equal to 0 this function is not defined. Here no point exists. So for continuous function there are 2 rules to be satisfied. One is function should have limit. For function to be continuous at point x0, function should have limit that should be exist at point x0. And second rule is function must be defined at point x0. So fx0 should be exist. We can take example of any continuous function. Let us take sin x. Now sin x is continuous everywhere, because if you see the graph of this function, then it is defined everywhere. If you put f is equal to x is equal to 0, then you can find value of sin 0, which is 0. In short, function is defined for each and every value of x. And you can find limit for each and every value of x. For example, if you want to find limit at this point x0, then you can follow similar process by finding left hand side limit and finding right hand side limit, and they must be the same. Here it is, let us say fa, it is same. So for each and every value of x, function is defined and it has limit. So we can say that sin x is continuous for every x. Now this condition can be asked in GATE exam. Now finally we will talk about differentiability of a function. Now for function to be differentiable, it must be a continuous function. So it must be continuous function. And second condition is, if function is differentiable at particular point x0, then limit x tends to x0, fx minus fx0, x minus x0 must exist. This limit should be exist. And third condition is, this limit should not be infinity. Now for example, let us say our function fx is something like this. It is like this. So at this point we have infinite slope. If you find slope of this curve at this point, then it will be infinity, because this is vertical line and vertical line has slope infinite. So at this particular point x0, this function is not differentiable. Now have a look at this function, which is fx is equal to mod x. Now this function is not differentiable at x is equal to 0, because if you take this second condition is not satisfied at this point x is equal to 0. Actually this formula is slope at any value of x. So if we take left hand side limit, that means if you take slope at left hand side to this x0 value, then it will be -1. And if you take slope of this function immediate right to this x0, then it will be +1. So these two slopes are not equal, and hence this limit do not exist. This limit doesn't exist, and hence function is not differentiable at x is equal to 0. So fx is equal to mod x is not differentiable at x is equal to 0. However, it is differentiable anywhere else. For example, if you take slope at this point, then it will be +1. If you take point which is immediate left to this function, then it has also slope +1. And if you take point immediate right to this point, then it has slope +1. So same value of slope everywhere. Now in next video we will do some example and we will look at some formula of limit.